What if the greatest discovery in human history didn't come from a new planet, a distant galaxy, or even a black hole? What if it emerged from a machine powerful enough to explore reality itself? For decades, scientists have searched for a single framework capable of explaining everything, from the smallest quantum particles to the largest structures in the universe. Every breakthrough has revealed another layer of complexity, suggesting that reality may be far stranger than we ever imagined. Now imagine combining one of the world's most advanced quantum computing systems with artificial intelligence designed to recognize patterns beyond human perception. Could such a system discover relationships hidden deep within the mathematics of the universe? Or would it simply remind us how little we truly understand? In early 2025, researchers reportedly pushed quantum simulations further than ever before, using AI to examine interactions at scales where ordinary physics begins to lose its familiar meaning. At these unimaginably small distances, space and time may no longer behave as smooth, continuous objects. Instead, they could fluctuate constantly, forming a restless quantum landscape unlike anything we experience in everyday life. The goal of the simulation was straightforward. Search for mathematical structures that conventional computers cannot detect. For hours, the system analyzed enormous amounts of quantum information, comparing billions of possible relationships between particles, fields, and spacetime itself. Everything appeared normal. Until it wasn't. Instead of producing another collection of statistical results, the AI repeatedly generated an intricate geometric structure. The same pattern appeared again and again. No matter how researchers adjusted the simulation, the geometry returned. At first, scientists assumed it was a computational artifact, an unexpected byproduct of extremely complex calculations. But deeper analysis revealed something surprising. The structure wasn't random. Its proportions remained consistent across different datasets. Even when entirely different starting conditions were used, the same mathematical relationships emerged. This immediately attracted attention. In science, patterns that survive repeated testing deserve careful investigation. Some researchers compared the geometry to naturally occurring fractals, structures whose shapes repeat at different scales throughout nature. Others suggested it resembled mathematical symmetries predicted by advanced theories attempting to unify gravity with quantum mechanics. No one could agree on its origin. The mystery only deepened when the AI began grouping these structures according to rules that human researchers had never programmed. Rather than simply identifying similarities, the system organized them into increasingly complex networks, revealing connections that had gone unnoticed for years. To many scientists, this wasn't evidence of consciousness. It was evidence that artificial intelligence had become exceptionally good at discovering hidden mathematical relationships. Even so, the implications were remarkable. If AI could reveal patterns invisible to human researchers, entirely new branches of physics might become possible. Some theoretical physicists proposed an intriguing idea. Perhaps information itself is more fundamental than matter. Instead of particles creating reality, reality could emerge from an underlying network of information, with space, time, and energy arising naturally from deeper mathematical rules. This concept has appeared in several areas of modern theoretical physics, although it remains highly speculative. Still, the AI's results encouraged researchers to revisit old questions with fresh curiosity. Could consciousness somehow relate to information? Could observation influence reality in ways we still don't fully understand? Or are these simply fascinating philosophical questions inspired by increasingly powerful technology? No one knows. But history shows that major scientific breakthroughs often begin with unexpected observations that refuse to disappear. Whether these strange mathematical patterns represent a profound discovery or simply a new computational tool remains uncertain. One thing, however, is becoming increasingly clear. Artificial intelligence is no longer helping scientists analyze data. It is helping them ask entirely new questions. And sometimes, as researchers continued examining the mysterious mathematical structures, an even bigger question began to emerge. What if these patterns weren't unique to a single simulation? Teams around the world started comparing the results with existing theories in quantum mechanics, cosmology, and information science. Surprisingly, certain mathematical relationships appeared similar to concepts that had existed for decades, but had never been connected in this way before. Instead of proving that the universe is conscious, the findings suggested something equally fascinating. Reality might be far more interconnected than our current models can fully describe. Some physicists proposed that information itself could be one of the universe's most fundamental ingredients. In this view, particles, energy, and even space-time might emerge from deeper mathematical relationships that remain hidden from direct observation. If that idea sounds extraordinary, remember that science has repeatedly transformed impossible ideas into accepted knowledge. Black holes were once considered mathematical curiosities. Gravitational waves remained theoretical for a century before they were finally detected. Even quantum entanglement was once described by Einstein as spooky action at a distance. History reminds us that today's mystery can become tomorrow's textbook science. Inspired by the simulation, researchers began building increasingly sophisticated models designed to explore these hidden connections. Each new experiment generated enormous amounts of data, revealing structures more intricate than anything previously calculated. Yet every breakthrough created even more questions. Were these patterns simply mathematical coincidences? Or were they exposing principles that had always existed beneath the surface of reality? Artificial intelligence played a remarkable role throughout the investigation. Rather than replacing scientists, it became a powerful partner, finding relationships across datasets so vast that no human team could analyze them alone. It highlighted subtle symmetries, unexpected correlations, and elegant mathematical structures that would otherwise remain invisible. Some researchers described the experience as exploring an entirely new scientific language. Others remain skeptical. Extraordinary claims require extraordinary evidence, and no responsible scientist was willing to conclude that the universe itself possesses awareness. Every hypothesis would need years of independent testing before earning acceptance within the scientific community. Still, the possibilities were impossible to ignore. What if future quantum computers become powerful enough to simulate physical systems with unprecedented accuracy? What hidden principles might they reveal? Could entirely new laws of nature emerge from those calculations? Or would they simply deepen our appreciation for the elegance of the universe we already inhabit? Around the world, laboratories continue developing more advanced quantum processors capable of performing calculations unimaginable only a few years ago. Combined with increasingly sophisticated artificial intelligence, these machines may reshape physics in ways we cannot yet predict. Perhaps the greatest discovery will not be evidence of cosmic consciousness. Perhaps it will be something even more profound, a deeper understanding of how reality organizes itself from the smallest quantum fluctuations to the largest galaxies spread across the observable universe. That possibility alone is enough to inspire an entirely new generation of researchers. Every scientific revolution begins with curiosity. Every breakthrough begins with a question. And sometimes, the most important discoveries are not the answers we find, but the mysteries that challenge us to keep searching. The universe has always guarded its deepest secrets behind layers of mathematics, physics, and imagination. Today, humanity possesses tools more powerful than ever before. Tomorrow, those tools may reveal discoveries that redefine our understanding of existence itself. Until then, one truth remains certain. The more we learn about the cosmos, the more extraordinary it becomes. And perhaps the greatest mystery isn't whether the universe is trying to speak to us. It's whether we're finally learning how to understand its language.